So good morning students. Today we'll discuss about Gauss-Jordan method, and this method is similar to our Gauss elimination method. Here the variables are eliminated from the rows both below and above the pivot element row. Unlike in case of simple Gauss elimination method where the variables are eliminated only from the below the pivot element row, but here both above and below the pivot element row the variables will be eliminated. That will result in a diagonal matrix rather than a triangular matrix, and where all the diagonal elements will be equal to 0, and the value of the augmented matrix will give you the value of the unknowns. We need not have to perform the back substitution, and in case of simple Gauss elimination method or with pivoting we have performed back substitution. In this case we need not have to perform the back substitution. The augmented matrix, that is formed by augmenting matrix B with matrix A. After the operations, after you make it a diagonal matrix, then what the elements in the augmented B matrix, B augmented matrix will give you the value of the unknowns, but it requires 50% more computational costly as suggested by Bargusami. So we will not write a Fortran code of it because it is seldomly used, and by the same method we will be finding the inverse of a matrix. That's why we will be discussing in details. Now we have a set of linear equations, and we know that we can write in the form of Ax and B, where matrix A comprises of the elements A11, A12, A13, A21, A22, A23, A31, A32 and A33. Matrix B is B1, B2 and B3, but when we augment matrix B with matrix A, this B1, B2, B3 will be represented by A14, A24 and A34 respectively. So our aim is to make the A matrix diagonal matrix. After the end of the operations we will see that it will transform into 1 0 0 0 1 0 0 0 1. So its A matrix will become a diagonal matrix, and the augmented matrix, that is the B matrix, after the operation will give you the value of unknowns. That means my x1 will be A14n, x2 is equal to A24n, and x3 is A34 times A34n. And represent the number of operation, the number of times the system has been derived. So the first, what are the procedures that need to be followed? The first procedure is we have to augment matrix B with the matrix A, and we will get a augmented matrix. That we have done. We have first augmented it, then we normalize R1 with A1. The row 1 should be normalized with A11, the first element of the first row, first column. Then we will get, here it will become 1, then A121, A131 and A141. That these elements are different from A12. That's why the first operation has been implemented, and other two elements, row elements, will remain as it is. Then we have to make A21 and A31 0. So how will you do it? So row 2 has to be replaced by row 2 minus the row 1 multiplied by A21, and row 3 will be replaced by row 3 minus row 1 multiplied by A31, and that will result in the first row will remain as it is, the second row first element will become 0, third row first element will become 0, and the system will derived as A221, A231, A241, A321, A331 and A341. After that we have to make A2211. So what we have to do, we have to normalize the row 2 with A221. Then my matrix will become 1, A121, A131, A4, A141, it will remain as it is, and 0, A321, A331, A341, it will remain as it is, but the row 2 will change as 0, 1, A232 and A242. After that what we have to do, we have to make this A1, A21 and A321 to be 0. So the row operation has to be done is row 1 has to be replaced by row 1 minus row 2 multiplied by A121, and row 3 has to be replaced by row 3 minus row 1 multiplied by A321. So my matrix will become G1 0 and A132, A142, because the operation has been performed here, and this row will remain as it is, and the third row 0 0 A332 and A342. Now the steps is we have to make A3321. So we have to normalize this row 3 with A332. Now the matrix will become 0 0 1 8 3 4 3, and again we have to make these two elements 0, so we have to perform the row operation. Row 1 has to be replaced by row 1 minus row 3 multiplied by a 1 3 2, and row 2 has to be replaced by row 2 minus row 3 multiplied by a 2 3 2. So at last we will ends up in a diagonal matrix 1 0 0 0 1 0 0 0 1, and these are the values of my augmented B matrix. So a 1 4 3, a 2 4 3, and a 3 4 3, which will be my the solution vector. So x1 is a 1 4 3, and x2 is a 2 4 3, and x3 is a 3 4 3. Now let us take one example. So if you remember this example we have taken to solve the values of x y z using Gauss elimination pivoting technique. The same example we will take, but we will solve using Gauss-Jordan method. So my A matrix is a 2 2 1 4 2 1 1 minus 1 1, B is 6 4 0. Now my first step is augmenting the A matrix with the B matrix. So 2 2 1 6 4 2 3 4 1 minus 1 and 0. Now after that I have to normalize row 1 with the first element of first row first column. So row 1 divided by 2, so it will, if it divide by 2, 1 1 1 by 2, and then 3, remaining these two row intact. After that row 2 has to be replaced by row 1 multiplied by a21, and row 3 multiplied by row 1 multiplied by a31. So after performing this operation, first row will remain as it is 1 1 half and 3, but the row 2 and row 3 will changes as 0 minus 2 1 minus 8 0 minus 2 half and minus 3. After that what we have to do, we have to make my a 2 2 to be 1, so row 2 has to be divided by the minus 2, so 0 1 minus half and 4, and then we have to perform the row operations to make these two elements 0. So row 1 has to be replaced by row 1 multiplied by row 2 into 1, and row 3 has to be multiplied by row 3 minus row 2 multiplied by minus 2. So minus 2 and 1. So after performing this operation, we will have 1 0 1 minus 1 0 0 minus half and 5. This row will remain as it is. After this operation, we have to make the a33 to be 1. So this we can do by dividing row 3 elements with minus half, and that will result in 0 0 1 and minus 10, remaining these two elements as it is. Then we have to make 1 and minus half this element 0. So this operation has to be performed. R1 is replaced by R3, row 1 minus R3 multiplied by 1, and row 2 has to be replaced by row 2 minus R3 multiplied by minus half and 1. So that will leads to 1 0 0 9 0 1 0 minus 1 0 0 1 and minus 10. So we see that A matrix is diagonalized. Now the value of the x, that is x y z, my unknown x vector, is 9 minus 1 and minus 10. That is x is 9, y is minus 1, z is minus 10. If you remember, then we get the same result in our pivoting case also. So thank you for watching.